for coming. Today we're going to talk about one of my favorite topic, which is Mobix. But I don't believe we have met before. So my name is Noaa Barki. I'm from Tel Aviv, Israel. I'm a full stack developer for more than 5 years, and I'm also one of the leaders of GitHub Israel community, which is the largest GitHub community in the whole world. Actually, no, it's the largest GitHub community in the whole universe. And well, on my spare time, when I don't do code, I really like to try to invent new recipes for beautiful and, I hope, delicious cakes. I also work at an amazing company called The Tree, where we help developers to prevent Kubernetes misconfigurations from ever reaching to production. If you want to read about us more, then you can go visit our website. But what are we going to talk about today? Today, we're going to talk about what is Mobix, why and how you should use it. We're going to learn how Mobix works under the hood. And me personally would like to share with you how Mobix almost ruined my relationship. So it all started 6 months ago. My boyfriend started to work at a new company, and it was his first time to ever develop in Mobix. One night, we sat down, we ate some dinner, we talked about work, and I asked him how things are going at his new job. And he looked at me and he said, "Noah, what is Mobix?" And I swear to God, I don't know why, I just immediately started to smile and I said to him, "Mobix is a library which provides tools for state management in a reactive way." Now, he's a very respected React developer, and he really, really likes to use React hooks. So he looked at me with a very confused eyes, and he said to me, "But I don't get it. If I already use React hooks, why should I use Mobix?" And then I said, "First, Mobix is a very performant library." And he said, "Yeah, okay, true, but that's also true about React hooks." And then we just started to fight. We started to argue mainly because I didn't know how to explain to him that Mobix and React hooks are just two different things. So we got into a really big fight and we talked about it for more than 2 hours until we broke up. No, just kidding. I'm messing with you. We didn't break up, and actually we're still together. But that night did turn out to be a very special night for me, because that night I started a journey. I started my journey after the meaning of Mobix. And my journey had 3 main goals, or 3 main questions, actually. The first was, why does it have to be reactive? The second was, what are the main concepts behind it? And last but not least was the first question, why shouldn't we use only React hooks? So in order to understand why does it have to be reactive, I first needed to understand what is reactive programming. Now, I went to my friend Joey from France because he always used to say that one of the most important things in soap opera acting is reacting. But this does not mean acting again. Unfortunately, with Joey wasn't very helpful because he wasn't talking about reactive programming here. So I had to dig a little deeper, and I found out that the best way to describe it is by an example. So let's take, for example, a light and a switch. So as we all know, as we flip the switch, the light turns on and off. Now I want you to think about it in coding terms. These 2 components are very coupled. So one approach is to have the switch modify the light, which makes the light bulb passive. However, the reactive way would be to have the light listen to the state of the switch and then modify itself accordingly. My own definition of reactive programming is that reactive programming is about automatically updating variables when other variables have changed. That being said, without the need for the program to re-execute. Think about it like an event-driven design application, but with one event and one handler. The event will always be, hey, I changed some data, and the handler will always be, okay, let's change some more data. Now, I hear you, and you're probably asking yourself, okay, but what does it have to do with Mobix? And for that, let me tell you a story. the story of how Mobix was born. So long time ago, at a small team in a company called Mendix, there was an app with many components. How many components? React wasn't fast enough for them. So the team started to look for an elegant solution for how to create a faster web application. They searched and they searched until one day they decided to leverage a concept from the world of reactive programming. The observable. Now, if you don't know what is observable, then you can think about it as a container that holds a collection of items. The items in the observable are added in an async way, like events. Now, this is the real magic. In order to access the items, you need to observe the observable, which means to watch its data. So whenever the data in the observable gets changed, the observer is notified and can get the new data. Back to Mendix, they loved the observable. Now they can happily compute values by observing the observable and re-render the components only if the data actually had changed. So they developed a solution. They called it Mobix, and they lived happily ever after since then. So now that we understand why does it have to be reactive, we can move forward and learn what are the main concepts behind Mobix. And I needed to start at the beginning, at how Mobix actually works under the hood. So let's start with the observable. In Mobix, observables are just a plain JavaScript proxies. Here on the left side, you can see an example of an observable that I have created using Mobix. Under the hood, what happens is that Mobix create a plain JavaScript proxy, which means that it wraps our object, our item, in a getter and in a setter function, so it can know when we access it and when we set it. Furthermore, under the hood, Mobix keep a dependencies tree of the observable that we have created. So for each observable, it keeps a set of its observers. Now, the reason why it's so cool, in my opinion, is because we don't need to do very much with Mobix. Mobix manages the observers for us. So, for example, let's watch item by adding a function that returns the total price of item. Now, what will happen under the hood is that Mobix will add total as an observer for item. So whenever the setter function of item will get called, Mobix will know about it and will know to execute total as well. But what happens when we set an observable? This is pretty interesting. Here you see 4 observables. 2 watches 1, 3 watches 2, and 4 watches 3 and 2. When we set 1 to a value, 1 will immediately send stale notification for all its observers, in this case, observable number 2. 2, in response, will send stale notification to all its observers, and then 3, and then 4. Then 1 will store the value and will send ready message, which means that it is stable, nothing can change anymore, plus whether it is actually changed or not. Now, this is very important, so I really want your focus right now. As soon as an observable received a ready message, for every stale notification it receives before, it can start to recompute. If none of the ready messages indicates that a value was changed, then the observable will simply tell its own observers that it's ready again, but without changing its value. So if you look at observable number 4 here, observable number 4 will only reevaluate after observable number 3 will become stable. And even more, observable number 4 will only recompute if either 2 or 3 had actually changed. I don't know what about you, but when I learned this, I fell in love with Mobix. Okay, now we can talk about concepts. And the first concept that I want to talk about is performance, because Mobix is very, very fast. Here's an example of a simple React component using React hooks. As you can see here, we have an input that on its onChange event, we call the handle onChange function, and we pass the set type here, the actual value of the input. Now, I want you to notice that the actual prop of the component will never get changed because it's hard-coded. Now, what do you think? When handle onChange gets called, do you think the component should re-render again? This is how many times the components got re-rendered when I used React hooks. And this is how many times the component got re-rendered when I used Mobix. Now, this is very important because this is actually the main reason why Mobix is so fast. So I want you to remember this. The reason why the component re-rendered only one time when I used Mobix is because Mobix knows that the actual value of the prop did not get changed. So the render function should not get executed. On the other hand, when we use React hooks, we actually change the state of the component. It doesn't matter if the component used it or not. I'm sorry, forget what I said before. This was the part where I fell in love with Mobix. Yeah, I'm pretty sure. Next, I want to talk about the fact that Mobix manages the observer's dependencies at runtime. So remember item from before? Remember when I said that Mobix added total as an observer? So I lied. Well, not entirely. Mobix will add total as an observer only when total will be executed. Now, this is pretty cool because this allows Mobix to have the minimal set of observers anytime, which also leads to a minimal times of renders, which is pretty cool, in my opinion. Okay. So as you can see, Mobix is a very performant library, and I really recommend everyone to read about it later, because now I want us to move forward to the next concept, which is my favorite concept, the data. Reactive programming is all about the data and the data changes. And because Mobix leverages reactive programming, Mobix provides the ability to separate the UI from the logic, which led us to be more focused on the data and the flows in our application. Now, this is very exciting because we are going to fulfill now one of my dreams, to have an ice cream shop. I call it Barki. Did you get it? Because it's a combination of my last name and gelato. I'm sure you got it. Okay, so, but before we start, remember that I said before that Mobix provides the ability to separate the logic from the UI? I say, let's take it to the extreme. What would you say if I tell you that we are going to create an entire application and we are going to play with the application, but without touching a single UI component? If not, if I'll fail, I'll promise, I'll get your money back. So what we would want in our ice cream shop, we'll probably want to display our flavors for our customers. And we want our customers to be able to place some orders. So let's add also a shopping cart. And we love money, so we want to have a payment logic. And finally, let's add what I like to call BL and validation for things like how to show that we ran out of flavor. Come on, nobody really likes to go into an ice cream shop and see empty trays, right? Okay, so let's start. Starting with flavors. Let's create a class called shop store, and this will be our store for the shop page. Now, we'll fetch the flavors from the server, and we want to display them on the screen when they are resolved. So let's add an observable for the flavors, and the function that will fetch them for the server. Now, do you see this little guy, the action? Actions is the way to update observables in Mobix. The special thing about actions is how they work, because actions work in a transaction mode, which means that Mobix will batch all the updates of the observables inside the action and will notify the observers only after the end of the action. Now, one more thing. The reason why I added the bound here is because when we use action, Mobix under the hood actually takes our function and wraps it inside another function. So at runtime, we might lose our scope. To avoid that, you can either use an anonymous function or use the bound here, just like I did. Your choice. Okay, so we added the action, we call it in our constructor, as you see here, and voila, it even works. You can see that when the flavors are resolved, we can see them on the screen. Cool. So next, we wanted our customers to place some orders. So let's implement a class, a shopping cart, with orders as an observable. We also wanted our customers to pay us. So let's add it also. And now think about it. This is shopping cart, so we would probably want to display the total amount of items and the total price of the shopping cart. And we are going to do it, but we are going to do it using the revisions. The revisions in Mobix are just functions that watch observable data. And there are several types of the revisions in Mobix. But the one that I want to start with is reactions, which are functions that watch observable data and produces side effects. The basic type of reaction is the Autorun, which is a function that accepts one function that should run every time any of the observable inside the Autorun gets changed. So as you can see here in the example, we are observing counter. So whenever it gets changed, this function will get executed. Under the hood, what will happen is that on the first time we call Autorun, Mobix will create an object called reaction in the dependencies tree, and it will add all the observables inside the Autorun as its observers, as you can see here. Now, surprisingly, there is another type of reaction called reaction. Under the hood, it works basically the same like Autorun, but the difference between reaction and Autorun is that with reaction, you declare the observables that you want to watch to. I really like to use reaction because it gives me more control of which observable I'm tracking on. So as you can see here in the example, the first argument of the reaction is the observable that I want to watch onto. And the second argument is the function that I want to execute when this observable gets changed. Now, when we increase counter, we will see the log on our console. And the last type of reactions that I want to talk about is when. And the when reaction observe an observable and run a predicate function until it returns true. Then it runs the side effect function and disposes itself. So as you can see here, we observe the counter, and when the counter will reach 777, this function will get executed. You can think about it like a function that you run only one time. The second type of derivations in Mobix is computed values. And there are functions that watch observable data and return a value based on the observable data. For a computed value example, I want us to go back to our ice cream shop and to add the total items in the shopping cart. So first, I'm going to use the computed decorator, and then I'm going to add the function that will return the value. So as you can see here, we are watching orders and call reduce onto it to calculate the total items in the orders. The reactive behavior that we get here is that whenever orders will get changed, total items will automatically recompute. And fun fact, by the way, computed values are memoized, which makes Mobix, in my opinion, way more awesome. Okay, cool. So let's continue. And yeah, that's it. Now you can see that we added the total items, and I already implemented for us the same logic for the total price, just for fun. And Now, all we have to do is we added the shopping cart to our shop store and we initialized it in our constructor. And now all that's left for us to do is to actually add the function that will add the flavor to a new order in the shopping cart. So let's add it over here. And voila. As you can see, we can add how many items that we want, and the shopping cart will automatically gets updated along with the total items and the total price. It's like magic, if you ask me. Last, I want us to make sure that our customers doesn't ask for a flavor that we can't give, because it will be very, very sad. So let's add a flavor class with a name, price, amount left, and an enabled property, which will be a computed value that will indicate if the flavor has ran out or not. We'll finish it by adding the logic for our shop store at the add flavor, so that when we add new flavor to an order, we need to make sure that we reduce the amount of the flavor. And as you can see here, it's magic like in Hogwarts. When cream is ran out, it automatically becomes disabled. Now, as promised, a live demo. Here is our application with our code in it, and we are going to hook into React. Okay, so use it. Let's see that we have what we want. Okay, so now this is the shop store that we have created, and let's add a new flavor. Let's add cream because we don't have much of it. As you can see, when we add cream, it's automatically got disabled and the shopping cart updated, and we can even remove the cream from our shopping cart. Oh, I'm sorry, I forgot here a breakpoint. And it's enabled again. And it's all from our console. Good. So the last tool that I want to show you guys is the observer, which is the way in Mobix to connect React components and actually to make them reactive. For that, you need to add the observer. You can either use the decorator or a function. And that's it, actually. The interesting is what happens under the hood. When we call observer, Mobix under the hood takes the render function of the component and wraps it as an Autorun. So it observes all the props in the component. So whenever a prop gets changed, the component will re-render, which is very nice, if you ask me. Okay, so now that we learned why does it have to be reactive, and we know how Mobix work under the hood and what are the main concepts behind it, I really, really hope that just like me, just like us actually, you can now understand and explain to others why shouldn't we use only React hooks. Thank you.